In this video, we're going to look at solving simultaneous equations by a method called substitution. So first of all, consider the equation y equals 2x plus 1. What's the solution? Well, there are lots of solutions, because we could have, when x is 3, we get 2 times 3 plus 1, we get y is 7. When x is 1, we get 2 times 1 plus 1, we get y is 3. There are actually infinitely many, because we could also put decimals in here. So there are infinitely many different answers to that single equation. So what we need is to have a second equation to be able to work out the specific solutions to this equation. And that's what simultaneous equations are. We have two unknowns, we need two equations. And we can solve them by substituting one equation into the other, replacing one of the unknowns, leaving us with just one unknown. So let's have a look at some examples to see what I mean by this. So here we have two equations. We have 2x plus y equals 5, and we have y equals 3x minus 5. And what we do is we take the fact that we know that y is equal to 3x minus 5, and in the first equation we replace the y with 3x minus 5. So we get 2x plus, well, instead of y, we have 3x minus 5, and we know that that is equal to 5. Now, once we've done the substitution, we just have to solve an equation in x. So we have 2x, in this case when we multiply the brackets, we just get 3x minus 5 equals 5. So we get 5x minus 5 equals 5. So we get 5x equals 10 by adding 5 to both sides, which means x is equal to 2. So x is equal to 2, but now we need to find the value of y, and to do that, we substitute x back into our original equation for y, which was y equals 3x minus 5, so y equals 3 times 2 minus 5, so y is equal to 6 minus 5 is 1. So the solution to this pair of simultaneous equations is x equals 2, y equals 1. A second example. Now this one we're not given an equation that's y equals, but we are still given two equations. And the first thing we need to do is to make one of the equations y equals. So we're going to do that to the second one because we have just a single y. And we're going to write that as y equals 7 minus 2x. And now we do exactly the same thing as before. We substitute in. So we have 3x minus 2, but then instead of y, we write 7 minus 2x. And we know that is equal to 0. Again, now we can solve it because we only have x, so we have 3x minus 2 times 7 is minus 14, minus 2 times minus 2x is plus 4x equals 0. So we get 7x minus 14 equals 0, or 7x equals 14, so x equals 2. Once we have x equals 2, we substitute that into our other equation. Y equals 7 minus 2x. So y equals 7 minus 2 times 2 in this case, which means y equals 7 minus, which is 3. So for this pair of simultaneous equations, x equals 2 and y equals 3. In this third and final example, we again have two equations. They are both of the form y equals something. So if they're both of the form y equals something, both 3x minus 2 and 2 minus x are equal to y. If they're both equal to y, it means they're equal to each other. So we get 3x2 equals y, but y is also equal to 2 minus x. Well, what we can do is just remove that y from the middle, and we get left with 3x minus 2 equals 2 minus x. And now we've solved the equation, so we add x to both. 4x2 equals 2, so we get 4 equals 4, x equals 4. And now we have x. We can substitute that into either equation. We're going to substitute it into y equals 2 minus x, which means y equals 2 minus 1, so y equals 1. So that's how we solve simultaneous equations by substitution. With them y equals something, and then every time we see y in the other equation, we replace it with what y was equal to.